Okay, is this a relation or a function? This is a relation. Why is it a relation? It's a relation. Actually, no, this is a function, sorry. Why is it a function? It's a function because a vertical line only hits the dots on the graph once. Okay, or the graph of, it only hits it once rather than more than once. Okay, so it's a function. X-intercepts, that's where that graph crosses the x-axis, so it's -3, 0. Okay. Y-intercepts, where the graph crosses the y-axis, so it's 0, 7. Or where the x-coordinate is 0. You notice how that's the case? Consistent amongst all those? Second, domain, you actually can't do domain and range using interval notation, technically. You can, but it's really, really messy. Okay, and we're just not going to do it for us. Okay, so we don't need to stress. When it's not a connected graph, we're not doing domain and range for us in interval notation. We can realistically only do it in set notation. So set notation is just the listings, domain, just the listings of the x-coordinates. So -7, -3, 0, 5, and nothing else. And then we throw it in some brackets for us. Okay, that's range, just the y-coordinates of each of those points since it's totally not connected. -3, 0, 4, and 7. Okay? Any questions? Relation or a function, it is a function because a vertical line only hits it once at any spot on the graph. X-intercepts, 0, 3, notice how the y, or 3, 0 rather, notice how the y-coordinate is 0. Y-intercept, the x-coordinate 0, so it's 0 that's like 4.7-ish. Doesn't quite get to 5. As long as you're close to 0.7, that's okay. As long as you're more than 0.5 and less than 5, you're okay. Domain, interval notation. The furthest to the left goes forever. Furthest to the right goes forever. Range, the lowest it goes, the x-coordinate of the lowest point, or the y-coordinate of the lowest point is 0. So it goes from 0 and to forever. It's a bracket because we actually get to 0. It's a parenthesis or at infinity because we can never get to infinity. We keep going and beyond. Okay, set notation now. A little bit different. Remember, the question changes. For domain, for set notation, it's not how far to the left, how far to the right. The question is what values can x be? That's our essential question for that one. What values can x be? So that's my question. What values can x be on this? Somebody answer that for me. What values can x be? Yeah, the x values can be absolutely anything, any value of x that you want to choose. So what we could have here is we could say that x is going to be everything, right? And that's that fancy R representing all real numbers. X can be any number in the world, all of the real numbers that we're talking about. Okay? That's at x equals R. For us, remember we have to do a little bit of tidying up on it, the brackets, right? And we say our variable is x, and we draw that line straight down. So it's like x such that x can be all the numbers. You have to have all of that stuff to get this question correct. Make sure you write all of that down for that spot. Okay, if you don't write that all down, it's not right. Okay, the next one, range, what values can y be? Because range is a question of the y's, right? So that's the question to me. Question to you, what values can y actually be? For the range, y can be anything from 0 and all the way up. That, in our world, is the word greater than. X can be greater than or equal to 0. That means 0 and up. And then we drop in the rest of the notation around that. Curly brackets, that represents it being a set of things in math. The set, such that or set for the variable y such that y is greater than or equal to 0. Ending the set. Okay. Backside. Ooh, don't want to show you the answers. Okay. Relation or function. This is a function. This one's yes, a function. It's a function because the vertical line only hits it once. X-intercepts. 1.1-ish 0 and 6 0 most. Okay. Y-intercept. There is a y-intercept, and that's I would say it's 0, 5. Notice how your y-intercept has an x-coordinate of 0, right? Okay. Domain. Furthest to the left is -3, but hey, it doesn't actually get to -3, does it? It's an open circle at -3, so it's a parenthesis, not a bracket. Furthest to the right is 7, and that's a bracket. Okay. Interval notation for domain. The furthest down is going to be like -5.9-ish. It doesn't like officially hit -6. It's like super close. If you wrote -6, we're still cool. Okay? Yeah.
If you wrote -6 with a parenthesis.
It has to be a bracket because, okay, if it gets stupid close to something, okay, if it gets really, really close to something but it's not going to get it, it'll be very clear that there's an open circle there. Does that make sense? Otherwise, if it's a line that's just near something rather than an open circle, then it's going to be a bracket. I see somebody else raised that same question last hour, so that's a great question. The question, let me repeat that. The question was, could it be a parenthesis on like -6 because it doesn't get to 6, but it's close? Well, it gets close, yes, but it's not, in quotes, stupid close because there's no open circle there because it's not creeping to it, okay? Okay? If there's no open circle, just know it gets to a specific value that it stops getting at. Okay, all the way up, 7.9 bracket. I would be okay with 8 as well on this one. Okay, set notation. Set notation. Set notation. It's a question for domain. Domain is a question of x's. Okay, and remember the question for domain and set notation is the essential question is what values can x be? What values can x be? X can be, the furthest to the left it can be is 3, but it can't actually get to 3, right? You guys agree with that? Okay, this is kind of the new learning that we're doing. X can get really, really close to 3, but not officially. So I'm just going to write -3 there. X can get to, officially gets to 7, doesn't it? It officially gets to 7. And X has to be squeezed between those two somewhere. The X value for all, the domain value, okay, for X, any X that's on this graph is going to be between -3 and 7, including 7. You with me on that? Okay. The way we show that is with inequalities in set notation. Okay. -3 is the furthest to the left. X, -3 has to be less than X. That's what this left side says. -3 has to be less than X. Okay. We don't put the underline on it because we can't be -3. But X also has to be less than or greater to 7 at the same time. With me on that? X has to be between -3 and 7, including 7. That's what that says. So we just write that up here. Drop some squiggly brackets around it. We need to declare in set notation that X is our variable. So essentially what the domain, the set notation for this one says is we have a variable X such that -3 is going to be less than X on the picture, and X has to be less than or equal to 7. It's kind of wordy. It's easier to just write this. Range, we do the same thing. Furthest down, okay, what values could Y be? Furthest down, we said was like -5.9. That's the furthest down. Furthest up, we said was like 7.9. And we know that Y is squeezed between there, between the -5.9 all the way down and the 7.9 all the way up. And it's allowed to be both of those numbers. It actually hits those values. It actually contains those values. It's including those values. Because, again, we can think including those values, the square brackets up top. Squiggly bracket, y such that. Because it range is a question of y's. Okay, question is graph a relation or a function. This is just a relation, right? Because a vertical line hits it 3 times, like right there, right? So it's not a function. It's a relation, just a relation. Okay, x-intercepts. There's 3 of them.
Is that negative 7.0?
Yeah, -7, comma 0. Y-intercept, 0, 3. Domain goes forever to the left and then stops at 3. So it's a bracket. Right. Range goes all the way down to -4, gets there, goes up forever. Domain and set notation. What values is x? What values can x be in this picture? Well, it goes forever to the left. Furthest right was 3. So it's everything to the left of 3, including 3, right? So left, that's less than, right? Everything x value lower than 3. So it's x is less than and including 3. With me on that? That's the hardest part of it. The rest is just memorizing how to write it fancy. Drop the rest of this stuff in. You have to have all that stuff. So it would be a good idea if you actually wrote this down on your notes. You knew that was coming. Range, the lowest, -4 and above, right? The graph starts at -4 all the way down and then goes up forever. So it's y is greater than including -4.